Hey guys, I'm back with another one. This is a follow-up video on the previous one, which touched on arithmetic sequences. And if we remember, if we just have to recap what it's about, an arithmetic sequence is a linear set of numbers that has a common difference. So what does it look like now again? This, for example, is an arithmetic sequence whereby we have this goes all the way up to Tn, and we have a series of numbers with a common difference, and we can see that each time there's a common difference of 3 between these numbers. So that is what an arithmetic sequence is, and there's a few common or a few characteristics about the arithmetic sequence that we need to remember, and these are things like the general term. The general term is an expression we can use to find any sequence, any number in the sequence, and we call it Tn. Tn equals to T1 plus n minus 1 times d, where T1 is the first term in the sequence, d is the common difference, and n is the number of terms in the sequence. And we calculate d. Let's write this over here. We calculate d by subtracting Tn from Tn minus 1. So it's the one number minus the previous number. So for example, if we in our sequence that we had, it's 1, 4, 7, 10. If we choose n to be 2, we're focusing on this number, so d would equal to 4 minus 1, which equals to 3. Cool. Alright, so we are about to embark on a journey into arithmetic series. So what is an arithmetic series? So before we get into that, let's just understand that the sequence is a very interesting thing, because it's a set of numbers that follows a specific rule. Now the series is even more powerful, because what we are going to do is we are going to add all of those numbers in the sequence to find one number at the end, and we will see why and how this becomes useful in real life applications later on. So firstly, there's a few things that we need to just touch on. Firstly, what is the sequence, what does the series look like? Sorry, an arithmetic series. So let's go back to our example. It was 1, 4, 7, and 10. Let's just take these four numbers for now. If our sequence is 1, 4, 7, and 10, our series, the arithmetic series, would be 1 plus 4 plus 7 plus 10. And what we then say is that S1, 1, 2, 3, 4, S4 equals to, that's 5, 12 plus 10, that's 22. So in this sequence, 1, 4, 7, 10, the series would be 1 plus 4 plus 7 plus 10, and the answer would be 22. But now, what do we do if this becomes exponentially big? We need a formula. We need something to assist us. And we have, through some geniuses, we've developed a formula to calculate the arithmetic series of as many numbers as we like. We can even go into infinity, or we can even go to infinity. We will touch on that a bit later. So let's just do this quickly. Sequences, and then we have series. I do hope that I have enough space. Let's see. Okay, so the general term, I'm not going to write it out because I've written it above there. The general term for sequences is as follows: T1 plus n minus 1 times d, and then we also have that d equals to Tn minus 1. Cool. Now when we look at the series, I'm not going to go through the derivation exactly. I'm just going to give you the formula to calculate the sum of the first n numbers, and I didn't explain it just now, but the series, or the sum, we denote with an s. So the sum of the first n numbers is equal to the how many numbers there are multiplied by the first term plus the nth term, and we divide all of that by 2. Okay, so we know that the nth term looks something like this. So Sn then changes to look like this. If it's T1 plus T1, we're just substituting Tn into this equation here, plus n minus 1 times d, all of this over 2, and this all just simplifies to n times, I'm running out of space. Let me write it over here. I'm going to continue over here. We know that Sn equals to n times 2t1. Oh, I'm not going to have enough space. Let me write it over here. I'll make it fit. 2t1 plus n minus 1 times d, and all of this over 2. Ooh, I hope that you guys can see that. I'll rewrite the equation on a later stage, but what we did was we just substituted for Tn into the equation and we simplified it. All right. I feel like I should write it here. Okay, so for an arithmetic series, we calculate the sum of the first n terms like this. It's 2t1 plus n minus 1 times d, and this all over 2. Okay, like I said, the derivation I'm not going to go through right now. I'm just going to assume that this is true, and I think the best way in which we can go further with this is by the hand of an example. Okay, so this is how we apply arithmetic series in real life. A stadium has rows of seats. The first row has 25 seats. Each row after that has 3 more seats than the previous row. How many total seats are there in the first 20 rows? Okay, so when we read this, there's a few important things that we need to extract and understand. So the first row is something important because that denotes our first term, and it says that that is 25. The next thing that we should note is that this part here, it says that it has 3 more seats. Each row after that has 3 more seats than the previous row. Okay, so this will be our common difference, and our common difference is noted as 3. And then finally, they want to know how many total seats are there in the first 20 rows, and n in this case equals to 20. So we need to calculate for Sn. Right? All we do is we plug it into our formula. Sn equals to n multiplied by 2t1 plus n minus 1 times d all over 2. And once we plug in our values, n is 20. 2 times t1 is 25. Plus n again is 20 minus 1. And our d is 3. All of this divided by 2. Okay, so some simple arithmetic, that's 50. If we multiply 2 by 20 plus 19 times 3, that is 57. All of this over 2. What I'm going to do now is I'm going to do that and simplify it to something like this. The 2 and the 20. 20 divided by 2 is 10. So I'm going to multiply 50 plus 57 is 107. And then we get that we have 1070 seats in the first 20 rows in the first 20 rows. Okay, cool. So this is one example of how we apply an arithmetic series to a real life problem or real life challenge. There is another one that I would like for us to go through. This one is a bit more involved. Let's see what it says. Emma starts a savings challenge. She saves 10 Rand a week. She saves 10 Rand in week 1, 13 Rand in week 2, and 16 Rand in week 3, and so on, adding 3 Rand each week. After how many weeks will she have saved exactly 1,155 Rand? And what will her final weekly deposit be? What will her final weekly deposit be? Okay, so again, we need to extract some information. we see that there's a 10 Rand in the first week, and we see that there's oopsie, not that part. We see that there's adding 3 Rand each week. That's something important. And we see that there's this number here, 1,155 Rand. So let's just see what our information looks like. T1 equals to 10, D equals to 3. We do not have N. That is actually what we need to find out. They're asking how many weeks. In this case, N is how many weeks. And then we have Sn, which equals to 1155. Okay. We also need to calculate Tn. That's the last thing. Oh, wait, just hold on, not Tn. Let me just fix this. Yes, no, never mind. Sorry, it is Tn because we don't know N as of yet. Alright, so we will start with our arithmetic series equation, which says Sn equals to n t1 plus 2t1 plus n minus 1 times d all over 2. And then let's plug in what we have and see what we are left with. So Sn is 1155. We don't have n. T1 is 10. Again, n is missing, and d is 3. All of this divided by 2. Alright, let's simplify this up and let's simplify this and clean it up a little bit. This is 20 plus 3 times n minus 1 over 2. Alright. Now, we would like to solve n, and it looks a little bit hairy, but I'm sure if we do this slowly, there will not be a problem. Right, so what we do now is we would like to get to this n is hidden behind quite a few operations, so we need to undo those operations to kind of uncover that n. So the first thing that we want to do is multiply by 2 on both sides. If we multiply 1155 by 2, let me just get my calculator because I don't want to get this wrong. Give me a second. 1155 times 2, that is 2310. So 1155 times 2, and that equals to, I'm gonna write this here, 2310. That equals to n times 20 plus 3 n minus 1. Okay, so that is what we're left with right now. The next thing I want to do is I want to multiply this n inside the brackets, because I need to eliminate these brackets, and I can't do any other operations within these brackets. So we will multiply the n in these brackets, and we will have that 20n plus 3n n minus 1. I will be continuing over there. It's 2310 equals to 20n plus 3n squared minus 3n. Okay, well, then we have 20. I would like to, okay, before we go further, we see that we now have a quadratic equation. There's a square term there. It's in descending order of the power of n. So we're going to rearrange it, and I would like to write it like a quadratic equation, like we are used to. So the first thing that we do is we write the 3n squared first. Then we say 20n minus 3n, that is 17 plus 17n. Oopsie. And then we have to subtract with 2310 on both sides. So this is minus 2310, and all of this equals to 0. So I am not going to go into the solving of this. You can use either factorization or the quadratic equation to solve this. But the one thing that I want us to note is that this negative means that we have one bracket that's positive and one bracket that's negative, and this is equal to 0. So one answer will not be applicable because we cannot have n to be negative. So this bracket will not be applicable. But if you put that into a calculator and you do the calculations, we find that n is equal to 30. So it will take her 30 weeks to save up the amount of 1,155 Rand. Um, it will take Emma 30 weeks to save 1,155 Rand. Okay, so there's one more thing that we need to do. We now calculated the 30 weeks, but there's one more thing that we need to do. They want to know what the final weekly deposit is, and for that we use our equation, our general term, Tn equals to T1 plus n minus 1 times D, and in this case it's 10. T30 equals to 10 plus 30 minus 1 times 30, not 30, times 3, and that equals to 10 plus 29 times 3, that's 60, plus that's 87, and T30 is 97 Rand. Okay, so to answer, our final answer is that she takes 30 weeks to save up 1,155 Rand, 1,155 Rand, and the last amount that she deposits is 97 Rand, and that solves our problem. Alright, so let's just do some recap. Again, what is an arithmetic series? And this is with all the sequences and series that we are going to cover. The sequence is just the set of numbers, and the series is adding the set of numbers up to a certain value of n. So say for example in this case, the last question that we had, we needed to add up till n equals to 30, so the 30th term. Yeah, so what is important is just I do believe that you are given the formulas, but personally I think that these formulas are simple enough to memorize or understand. It would be a good exercise to go through the derivation of this this formula right here. But yeah, that is it. Thank you so much for watching. I do appreciate your time. Yeah, don't hesitate to drop a comment or suggestion and a like, obviously. Thank you very much. Cheers.